All right, guys, second half of the 4-2 notes, we're going to be comparing standard form of a quadratic to the vertex form to the factored form. So we learned how to convert from standard into vertex during Unit 3, and then the factored form is something that we've just been practicing for the last couple lessons. So to go from standard form to vertex form, we're going to remind you of this step-by-step process that we had in Unit 3. So it goes like this. First thing that we do is we take the first two terms, the x squared minus 8x, and we would group them together like that. Next step is you would factor out whatever's in front of the x squared if there is something, which there is not. Step 3 is we take b, cut it in half, so that gives us a -4, and then you would take that -4 and square it, so that gets us 16. Okay, so this next part is still kind of part of step 3. Once you have that 16, the next thing you do is you take it and you add it inside of the parentheses that we have right here. These boxes aren't super wide. Okay, so that's step 3. Is the only thing that changes from this line to this line is I put this value in here. Step 4 is you take the value out front of the parentheses, which is technically just a 1, multiply it by this number, so you have 1 times 16, and then you subtract that number. All right, and last step is you would factor down the parentheses. That's a perfect square trinomial. So this is going to factor to x minus 4, x minus 4. So remember, in vertex form, we write it as x minus 4 squared, and then these two values simplify down to just a -1. So remember, what this tells you is that our vertex is the opposite of this number, so +4, and then the y is this exact number. So it tells us our vertex. It also tells us our axis of symmetry, which would just be this exact x value. So our axis of symmetry is just x equals whatever that x value is. So we can do that. Another form is the factored form, which is really easy to get to if we have this standard form right here. Okay, so factored form, we do f of x equals, and then since we have everything on one side here, what we want to attempt to do is write it in this form, so practicing a little factoring like we were doing the last couple lessons. So multiplying to a +15, adding to a -8. We know it's going to be negative, and to multiply to the 15 would be 5 and 3. And when I add those values, then I end up getting -8. So our roots, or our x-intercepts, in this form, if I took each one of these and set them equal to 0, if I set this equal to 0, I would get 5. If I set this equal to 0, I would get 3. So my roots are 3 and 5. So now from all three of these forms that I have, it's going to be pretty easy to just come up with the graph. Okay, so my roots are my x-intercepts. So I have a root right here. I have a root right here. And then this tells me that my vertex is 4, -1. So 4, -1 would be this point right here. And my axis of symmetry is x equals 4. Okay, so we've got a nice little bit of information right here that we can use. We didn't even have to do anything extra. We just kind of combined the information that we had from those two different forms. All right, so that was this first type right here. Second type that we can look at, this one right here where we have something out front. So we're going to walk through that one. Step 1 is still just that you group these two things together. So the -2x squared minus 4x and the +6 is separate. Step 2 is you take whatever's in front of the x squared and you factor it out. And when you factor it out, make sure that you're actually factoring it from what's in parentheses. So you'd have an x squared left here, and when you divide this term by a -2, you're left with a +2x. Do not touch the +6 on the outside. Step 3, take this middle term, which is a 2, cut it in half, which gives us a 1, and then once you come up with that 1, you square it. Okay, so that's step 3. We're actually still going in step 3. You would also take this one and add it inside the parentheses. All right, so we have f of x equals -2, and then we have x squared plus 2x plus 1. So doing that finishes off what we have for step 3. Step 4 is you are going to take this value times this value, so -2 times 1, which is a -2, and you are going to subtract it from the end of the equation. Okay, so -2 times 1, so we are going to subtract a -2 from the end of our equation. All right, then finalize it here. So -2, this factors down to x plus 1, so we write it as x plus 1 squared, and then these combine up to an 8. Okay, so that is our vertex form. This tells us that our vertex would be -1, +8. And knowing this x coordinate tells us that our axis of symmetry would just be x equals -1, just matching this x value. Okay, so a little bit more work for that one. Let's also get it into its factored form. So based on this right here, you can do a slide and divide to get it into factored form. So I'm going to do that. So this can take f of x equals, I am going to slide divide this -2. So I will have x squared minus 4x, and then I slide this and make this a -12. So that's where I'm at so far. Then factor it down just like normal. So I do x times x, and then I'm looking for what multiplies to a -12, adds to a -4. So that would be a -6 and a +2. And then remember, we finish it off by dividing everything by a -2. Okay, so we've got that. So this reduces down to a +3. And then this reduces down to a -1. Okay, so that is our factored form. So we've got our roots. So when I solve for this, we get -3. And then when I solve for this, I get 1. So this form is just going to tell me where my roots are. So graph them. Here is an x-intercept at -3. Here is an x-intercept at +1. And then it tells me where my axis of symmetry is. So this -1, +8 would be right up there. So now that I know all 3 of those things, I can just connect the dots, make my parabola, and if you want, your axis of symmetry runs right down the middle of that as well. Okay, next type that we're going to do. This type right here, we're given the one in vertex form. So if we want to get it into standard form, what you do is you basically just expand this entire thing. So I'm going to start with standard form. So very first thing that you would do is you would take this x minus 7 squared, and you would write it out twice and end up foiling it. So I'm going to leave this negative out front for right now while I FOIL this. So I have x times x, which is an x squared. Outside is x times -7. Inside is x times -7. So it ends up being a -14x. And then the last is -7 times -7, which is a +49. And then a +1 on the outside. So this negative needs to be distributed. So I have a -x squared, a +14x, a -49, and then this +1 is just kind of tagged onto the end. So finally, last step, I would just combine up the -49 and the +1. So that would be my equation in our general form. Now we can turn that into factored form. Here's something you might want to do that probably would have made our lives a little bit easier if I had done it here. If there's something out front, it may be a good idea to factor it out as you're trying to get into this factored form. So factor out a negative from all 3 of these terms right here. That'll make things easier to factor. So I am going to keep my negative out front, write down what my 2 factors would be. So x squared is x times x. And then I'm looking for 2 terms that multiply to a +48, add to a -14. So that would be a -8 and a -6. So that is our factored form. All right, so this are roots. I end up with, when I add 8, I get a +8. This gives me a +6. So my roots are 6 and 8. Oops, should have been a squiggly. And then this, my vertex, would be a +7 for x and a +1 for y. So I can use these 3 things to do my graph over here. So 6 and 8, x-intercept here, x-intercept here, and then 7, 1. So this would be 7, 1 would be my vertex. Okay, so we've got those 3 points. It's not a ton, but it's enough to show where your graph is going to be. And remember, your axis of symmetry always just matches the x value that this ordered pair has. So you can run your axis of symmetry right through that point right there. Okay, so that is the one where we convert from vertex form. So I feel like we've practiced that. Let's skip over the next one. Let's go to where we start in factored form. Okay, so when we start in factored form, that's actually pretty straightforward to first get it into standard form, and then we can turn that into vertex form. So what we do for this is I'm going to write down the factored form first, just so you see where all this is coming from. So write it like this. And then for standard form, all you're going to have to do is FOIL it out and simplify it. So f of x equals, if we FOIL this out, we have x times x, which would be x squared. On the outside, we have x times 7, which would be a 7x. Inside is 3 times x. And the last is 3 times 7. Sorry, I'm going to sneak that in this box, plus 21. So combine up like terms, nothing too crazy here. So this combines up to a 10x and then 21. And that's it. That's ax squared plus bx plus c. So it's pretty easy to get from factored form into standard form. And then on the previous page, we already had practice going from standard form to vertex form. So let's finish off that one last one. So step 1 of this conversion is you take these two first terms and you group them up together in parentheses like this. Step 2 is you would take anything in front of the x and factor it out, which we don't have to do because there's nothing in front of the x. Step 3 is you take b, which is 10, cut it in half, and that gives us 5. And then you take the 5 and square it, so that gives us 25. All right, so next thing to do, finishing off step 3, we're still on this step, is you would add this 25 into the parentheses. So I'm going to rewrite my first line. The only change I'm going to make is just adding the 25 into the parentheses, like that. Okay, and then step 4, you take anything out front, multiply it by the 25, and subtract that. So 1 times 25, I'm going to subtract that off of the end of my equation. And then just simplify it up. So you factor what's in parentheses. So this x squared plus 10x plus 25. Remember a quick trick we had from the last unit was that this number is just half of this number. And then you can write it in this form. So half of this is this. When I square this, I get that. And then these combine up to just a -4. So vertex is the opposite of what I see next to the x, and then the same as what you see after the squared. So you've got the vertex, the axis of symmetry, remember, just shares the same x value, just like that. And then we also can use this to come up with our roots. So we have, when we set this equal to 0, we get a -3. Set this equal to 0, we get a -7. So let's finish up with our graph. So x-intercepts are at -7, which would be right here, and -3, which is right there. Our vertex is at -5, -4, and our axis of symmetry is just a dotted line right through that vertex. So parabola, just connect the dots and put arrows on both sides.